barium ions as a tool to be able to cool molecules. So we trap ions, barium, which has a +1 charge, and we trap it in what's called a Hall trap. So we have basically 4 rods like so, and the other 2 are behind these, and then we have plates over here. And looking down this way, 4 rods are like this. And what we do is, in order to trap these ions, we put a radio frequency voltage, basically just time oscillating voltage, on those 2 rods, and we ground these. So what an ion sees in the center here is inside the level structure of barium. It's like this. And these are the cooling transitions here. So this one is 493 nanometers, and this one here is 650 nanometers. So in order to cool, we drive primarily this transition, so it cycles back and forth along here many times before every once in a while it'll fall into over here. So there now, you see the 4 different rods? Yeah. And then the metal end caps. So that's the entirety of our trap. And currently, we have barium ions in it. That camera is live of the different barium atoms fluorescing inside the trap. So because you can see the individual ions, they're very cold. It's actually formed a crystal in there. So they have the trap pulling them all together towards the middle, and then since each ion repels itself, they kind of each fall into a local area where they're happy energetically. That's what allows that. If they're hot, they'll get very blurry, and we'll show that in a minute. So continue. My interest in this research that we're doing is in precision measurement. So you all saw Chenyu in the lab. He is the one who devised the experiment that I showed you, and I'm going to be taking that experiment over from him once he graduates from here, and taking that to the precision limit. So he's going to do basically the first part of the experiment, and then I'm just going to take it the next step further from that. Because it's the types of experiments that we should be able to do are a different way of doing some measurements that would otherwise take things like the LHC, and I got very excited about that. So that's how I ended up here. And then relationship with Brian, I really love working with Brian Odom in his lab. He has some amazing, fantastic ideas that I just hope in my time here that we can fully see we can help him achieve some of his vision, because I know his vision is very, very grand.
And what are some of the obstacles you guys have encountered?
Graduate school is more of overcoming obstacles and problems that arise in what would be something on paper that's very simple. In our lab, for example, I came here now more than 2 years ago, so this is the start of my 3rd year. At that time, we didn't have a working trap. In an experiment, if you stop them, as soon as you stop them, about 2 microseconds later, they'll decay.
So I think with that, because it's a little past 5:30 now, we should probably stop. But